Hello there, welcome to another lesson about fractions. Here are 3 get-ready questions to warm our brains up. Give them a go. Number 1, we can see we have 5 equal parts of the bar and 3 are shaded blue, therefore 3/5. Number 2, we have 8 equal parts of the bar and all 8 are shaded green, therefore the fraction that's shaded green is 8/8. And number 3, well, we can see we have 5 parts shaded yellow. Here we have a number line, and we're going to count up the number line in halves. So we jump on a half, and we'd mark 1 half there. Add another half, and we're going to be at 2 halves. And another half is 3 halves, and another would be 4 halves, of course. Let's show that using a bar model. Here we have 2 halves, 1 half, 2 halves. We can see when we've shaded 2 halves, we've actually shaded 1 whole. So 2 halves is equal to 1 whole. How about if we have 3 halves? We can see from our bar model 3 halves is equal to 1 and 1 half. And 4 halves is going to be equal to 2. Here we've got a representation of some halves. We know we're dealing with halves because we can see for each bar there are 2 equal groups. Therefore our denominator is going to be 2. What's the numerator going to be? Well, 3 of the halves are shaded. Therefore our numerator is 3. 3 halves. You can see here that the numerator is greater than the denominator. And where we've got a fraction like that, we call it improper. An improper fraction is where the numerator is greater than the denominator. We can write improper fractions in a different way though. We can see with our 3 halves we have 1 whole and then 1 half. Therefore, we could write 3 halves as 1 and 1 half. 1 and 1 half is an example of a mixed number. A mixed number is a number that has a whole part, in this case 1, and a fraction part, in this case a half. Those two mean the same thing. 3 halves is equal to 1 and 1 half. They have an equal value. Have a think about these 3 representations and how they show mixed numbers and improper fractions. We can see on the number line, if we count up in thirds, 1/3, 2/3, 3/3 is of course 1, we can see the arrow is pointing at 1 and 1/3, which we could write as 4/3 as an improper fraction. With the bar models, if we moved that 1 shaded section to the whole there, we can see we have, in sixths, we have 10/6 shaded, and we can also see from the bar model that that is equal to 1 and 4/6. There are the equivalent fractions to the improper fraction and the mixed number. And with the cylinders, we can see we have 2 complete cylinders filled and then half a cylinder, 2.5 cylinders. As a mixed number, well, if we halved those full cylinders, we can see we have 5 halves. A key skill is being able to convert, that means change, an improper fraction into a mixed number. Here's an improper fraction, and we've shown 7/3 using some circles. It's really easy to see when we have a picture like this that 7/3 is equal to 2 wholes and 1/3. Therefore, as a mixed number, 7/3 is equal to 2 and 1/3. Over to you. Write this fraction as an improper fraction first, where the numerator is greater than the denominator, and then write it as a mixed number. The first thing we need to do is establish what the denominator is going to be, and we can see by looking at the first bar we're dealing with sixths. How many sixths are shaded? There are 23 sixths shaded. And as a mixed number, we can see we have 3 wholes and 5 sixths. There's the improper fraction and the mixed number. Over to you to have a go at questions 1 and 2 on the worksheet. Here's another improper fraction to convert into a mixed number, 32/7. we know that 32 sevenths means 32 divided by 7, and were we to carry out that division, we would see that the answer is 4, remainder 4. However, we're now going to change that remainder from remainder 4 to 4 sevenths. Why can we do that? Let's use a bar model to help us understand. Here's that same improper fraction that we've just seen. And we've just said that 32 sevenths is the same as saying 32 divided by 7. Why? Well, let's take that fraction, 1 quarter, 1 over 4. To show that in a bar model, we'd show that. We'd take the whole and we'd divide it into 4 equal pieces. Therefore, 1 quarter means 1 divided by 4, which means that 32 sevenths means 32 divided by 7. Let's show that using a bar model. If we were going to show 32 sevenths on a bar model, we'd need sevenths, which we do have on each row, and we're going to shade in 32 of them. And there we've shaded 32. So we've done 32 divided by 7, or 32 sevenths. Looking at the bar model, 32 divided by 7, or 32 sevenths, well, we've got some whole numbers, 1, 2, 3, 4. 4 whole numbers, or 4 wholes. And then we have, if we did the division, we would have remainder 4. But we can see from the bar model that that remainder 4 is in fact 4 sevenths. Therefore, 32 sevenths is equal to 4 and 4 sevenths. Have a go at converting those mixed numbers into improper fractions. 107 tenths, well, 100 tenths would be 10, so that's going to be 10 wholes and 7 tenths. 22 thirds, 21 thirds would be 7, so 22 thirds is going to be 7 and 1 third. Here's a very interesting problem. Find the value of the star and the rectangle. In that situation, we have 25 over the denominator is star, so we're thinking an improper fraction, is equal to 8, and the rectangle is the numerator, and the star is the denominator. We'll go through this together, but over to you to have a think about your strategy for this problem. Let's work through this together. We've seen so far in this lesson that a fraction can be written as a division. 1 over 4, 1 quarter, is equal to 1 divided by 4. Therefore, the fraction 25 over the star can be written as 25 divided by star. 25 divided by star is equal to 8 remainder rectangle. And we saw previously that the remainder becomes the numerator in the mixed number. We can rearrange that number sentence so it looks like that, and then we can carry out 25 divided by 8. But why can we do that rearranging? Well, it's because of something we know about division. We know that 12 divided by 3 is equal to 4, for example. So we can rearrange that to show that 12 divided by 4 is equal to 3. And that's just what we've done with the 25 and the star and the 8. Let's carry out that division, 25 divided by 8. If we carry out that division, 25 divided by 8, we're going to have an answer of 3, remainder 1, which makes sense, because 24 divided by 8 is exactly 3. 25 divided by 8 is 3, remainder 1. So now we can see that 25 divided by 3, or 25 thirds, well, that's going to be equal to 8 and 1 third, because 24 thirds would be equal to exactly 8. We can show that with some bar models. There we have 25 thirds, and we can see we have 8 wholes and 1 third. Therefore, back to the original question, the star is worth 3, and the rectangle is worth 1. The denominator is the star, thirds, and the rectangle is the 1, the numerator. You're now ready to finish off the worksheet for this lesson.